All right, today we're going to talk about our measures of spread and standard deviation. So far we've used numerical measures to describe data sets. We focused on mean and the median, and they tell us the measures of center and the most typical value of the data set. But if we were asked to make a prediction about a member of the data set, we would use a measure of center to predict that value. However, measures of centers do not give us the complete picture. So let's look at this score. So we've got Johnny, who scored 65, 82, 93, and 100 on the different tests. And then you have Will here. These are his scores for each test. And then Anna here, those are her scores for those tests. So who's the best student? How do you know? First off, let's find the average test score for each student. Well, if you notice, if you were to add all these up, and then divide by 4. So that's what you would get here. Same thing for Will, and then same thing for Anna. So right now we can't tell who's the best student because they all have the same average. So let's look at the mean. So we want to see how consistent they are on the test. Does each student tend to do about the same, or does it vary a lot from test to test? So if you notice, Johnny here, he's got a 65 on one test, 100 on the other, then kind of in the middle. Will was pretty consistent in the 80s. And then Anna, you've got a 99, you've got a 73, you've got an 80, and an 88. So she's kind of around too. So the standard deviation, we could use the measures of spread to figure out who the best student is. So the standard deviation is a measure we can use to describe the spread when we use the mean as the measure of center. So standard deviation of a set of data is a number that indicates how much the data deviates from the mean, or how far away it is. So the larger the standard deviation is, the more spread out the numbers are. The smaller the standard deviation is, the less spread out the numbers are. And then the smaller standard deviation means those are more consistent. All right. So you're going to see it's a Greek symbol here, and it looks kind of like a O with a little tail on top. That's sigma, and that's the standard deviation of your population. And then this is standard deviation of a sample. So that's your sample size. All right, now for the formula, this is the formula. We'll talk about that a little later, but basically it's the sum of the numbers of the average from before, and then it's divided by the sample size. All right, so we're going to use standard deviation by using Desmos. So it says enter the data values into the X1 in a table, go to functions, go to stats. And then this is important. Make sure you use the stdevp, and then we want to put in X sub 1 for the standard deviation. So I'm going to show you what we're going to do. Whoops. I already typed in the values for you. So if you look here under X sub 1, I typed in these values. So in order to get the standard deviation, we're going to click down here, and we're going to go to where it says functions. Now under functions, we're going to look at the statistics, and we're going to go, again, be careful because this looks very similar, but we want the one with the P in it. Okay, and then since these are Johnny's scores right here, so X sub 1 is Johnny, I'm going to type in X1, maybe. Oh. There it goes. All right, and then if you notice, I've got 13.209. So that's the standard deviation. That's how far it is from, so when I come back here, I rounded that, so we said that this is 13.209, which says 13.21. So we said Johnny's test score varies about 13.21 points from the average. Now let's look at Will. He's got a pretty small, so I did his information too. I put his under Y1. So now I'm going to go here, and I'm going to go back to functions, and we're going to go to the same button, but this time I'm going to type in Y1. And then if you notice, that's the standard deviation for Will. And then since we're here, we're going to go ahead and we're going to do for Z1, same thing. And then we got 9.669, so 9.7 as far as those points. So when we go back to here, and we're looking at the information, go ahead and make sure you're writing all this down. So we said Will was 2.12, so Anna's sigma was 9.67. So Will had a very small standard deviation from his average, and then Anna was kind of in the middle with 9.67 from her average. So based on this information, we're going to say Will was the best student because he was the most consistent and he had the smallest standard deviation of the three. So now let's go through, consider the following symmetric distributions. So here when you're looking here, if you notice the standard deviation, there's a larger standard deviation, so it's not as consistent, versus this one, there's a smaller standard deviation there. So data sets with larger standard deviation will be shorter and wider, like this one, because the data varies and is more spread out from the mean. Data sets with smaller standard deviation will be taller and skinnier because the numbers vary less. So there's more within this value, which would be the smaller standard deviation. So now let's look here. It says which data set has the largest standard deviation? Well, they all have whatever M is. So let's look at how far it is from there. So if you were to combine, put all of those into the table, get your standard deviation to be 1.92. And then same thing here. Combine those, get the standard deviation, and you get 1.58. And then for C, you got 3, -2, -1. And then this one is missing a value, so that's where they got the 0. Oh no, here's the 0. This is a 0. Sorry, I read over that quickly. So this would be +0 right here. All right, and then combine those together, and you have a standard deviation of 1.80. So if we want the largest standard deviation, it's going to be 1.92, which is option A. All right, so just remember when you're doing standard deviation, and if you're using Desmos, go ahead, you're going to put everything into your column, and then make sure you're going to functions, and you're doing the correct ST. Oops, got way too many numbers there. But, and then whatever column you're looking for your data, you can put that in there. All right, and then that is standard deviation, measures of spread.